stepping stone. Let's see how you can develop this and take this further afterwards. But thank you. So I'm not sure how many are presenting today. Hopefully everyone will present. But let's start off with Matthias and Lija.
All right. So hello everyone. My name is Mateus. Can everyone hear me correctly? Is it good? Is it good?
Yes. Yes.
All right. Let me share my screen. Okay. So I've been looking at different things since the workshop, and I'm gonna present 4 different things real quick. But everything follows a line, so I don't want anyone to get lost. So the first thing is the part of the workshop that we looked at using CycleGANs to generate different variations of Barcelona. And just to explain the data set, so we used 2 different training models. One is the different satellite images of Barcelona, and I used a different image that we used in the actual workshop, but it's the same city. And then the script for this generated labels for the city. So using colors to, in a way, give to the network some sort of guide to what we're looking for and the patterns that we want to recognize. And here a little timeline, more or less the amount of hours that it took for the CycleGANs to start understanding the different patterns and generating these new models for the city. So I'm not going to show the video right now. Well, I can show the video. Let me see if I'm sharing my audio. Just a second. So I looked at this different versions of the city, and I figured out what could be a way to represent this new models of Barcelona in 3 dimensions. So just show this. So the video is a bit dramatic, but it's just to showcase this idea of using these different iterations of Barcelona and getting the same way that we use samples of colors to generate the patterns, using the colors to generate the estimated heights for this new variations. And as you can see here, this corner is what we're looking here with this preliminary topography of the new variation using a grasshopper script, right? And with this technique, I can get different variations and different iterations as the computer generates more Barcelona and quickly like showcase them in 3 dimensions. But then I came to the conclusion that this is, even though it's a workflow that allows us to visualize in 3D, the actual GANs, right, is not understanding the city in 3D. It's just a representation of the image. So again, this was my favorite epoch, so I wanted to showcase. But then I started looking at different ways of what people have been doing to understand it in 3D. And so I looked at Sofia Crespo, and I don't know if you guys know who she is, but she's one of the leading artists right now in AI. And I came across her work by mistake. It was a beautiful mistake. Biana directed me to her. And one of the projects that interested me the most is the artificial remnants, which she took a bunch of different 3D models of insects, and she generated new iterations of 3D geometry based on what the software understood of the existing insects. And then she used AI as well to generate the patterns and the textures onto the models. And then she used GPT-2 to generate the scientific names for this new insect. So in a way, it's a compilation of all of these data and 3D data of existing to generate this new nature in a way. And then this is augmented reality of one of these insects in my living room, and one of these on top of Lija's head earlier today. She didn't see that. I'm sorry, Lija. But then I I was very curious about that, and I started trying to learn the ways of doing that. So for my first test, I made this little model of a hut, trying to understand, okay, a basic idea of a structure, just to test this idea of incorporating the mesh into the neural network. And I was able to run a test sampling from a sphere, exploding this mesh into like a point cloud, and then morphing this in order for me to understand the process and the workflow of working with objects in PyTorch 3D. And then I'm coming to a new part, which is the materiality and more towards the neuroscience, which I'm most interested about, space and AI. So I'm looking at this piece of art that is also by Sofia Crespo, and she did this project that she called Trauma Doll, which is a combination of these collages that she started making with some health problems that she was having and the medication she was taking. And then the AI started generating all of these different posters that basically she describes as an artificial neural illness, but they're all a combination of negativity and self-thought and all of these different things. And she even said in an interview that she feels like it became something else. It became its own thing. Well, her quote is, "I already feel like it's not me anymore. Maybe I'm working with it, but I feel like Trauma Doll in itself is something independent. It's hard to explain it, but it's as if it lives by itself, as if it already decided what it wants to be." Sometimes I look at the pieces and I think, what is that, right? So I was thinking of that, and then basically I had trained a model in StyleGANs, which I showed the class, generating different versions of wood. So all of this data that you see here are GAN generated wood textures. And then on top of that training, I inputted different pieces of this artwork with these different iterations of this trauma doll. And then the result was a mix of wood textures and trauma doll, which became, in a way, a texture for this trauma wood. Right? And funny enough, if you look at it, all of the words into the trauma wood got inputted in something that looks like zeros and ones, which I'm sure it wasn't intentional, but it looks like lines and paragraphs of zeros and ones, which, I don't know, scary. But then to use this material somehow, I started looking at ways that I can take the geometry, and I took the hut again, and with a very sketched, texture onto the geometry, how to hallucinate this idea of the trauma wood into a 3D geometry as well. So in the end, it mimicked somehow the existing texture onto the geometry with this trauma, creating sort of a representation of this feeling that AI hallucinated into the posters into a spatial quality in a way. That's it from me.
Great. I mean, let's actually, I'd be worthwhile having some immediate feedback. I think Matthias is here, which is great. And Matthias has been working with PyTorch 3D. And so he has some experience of that. I've never got no experience at all, but anyway, comments, feedback? You've done a lot of work, which is thank you. That was really impressive. Just maybe I could ask one question. I mean, in terms of the neuroscientific side of things, how did that really play out, or was there much of that in the end?
In the end, it was. I haven't really dove much into it, but it's the idea of starting to use these images. For example, she did the entire trauma doll. It's the result of that. And even though I don't believe that the AI is truly feeling those things, but in a way it successfully mimics our trauma and our depressive thoughts and is able to portray into a poster. So I'm interested in that side, and my plans for this next couple of weeks, I have a meeting in less than a month from now with a the head of neuroscience actually in FCU in Tampa, FMA. Anyway, it's the med school in Tampa, and to connect this idea of getting real life data of neuro or biometrics and converting them into spatial qualities. And it was really funny because today's Digital Futures was a lot of presentations about this, and I went crazy, and I'm excited to dive more into it. But this was an initial test on these workflows that involved these different networks, part from what we learned with Daniel, and part with more research on top of that to figure out these workflows.
Yeah, I think it's great. There's a lot of work done in just 1 week, and for such a short workshop, because we didn't really have time to really go in depth in everything. But I think what's something important that you have to probably understand from here is that mostly everything that it's AI depends on data. So the data that you have, that's the one that matters. Yeah, AI without data is nothing. It's just an algorithm. Yeah. So then the way that you're structuring your data and how you play with that, I think that will play a huge role in the results that they are going to have. If you look at Barcelona, yeah, those results are super interesting. If you look at 3D conversions, you just have to figure out then a way how to encode 3D information, yeah, for that network. Because for me, it's always, I understand that there is a push for 3D, but the networks themselves, I think they are able to read 3D. It's just that we don't have yet a very way of creating a data set that is 3D and that is homogeneous, yeah? The reason why images are so easy to work with is just because an image is homogeneous, yeah? It's the first pixel is the same first pixel in all the images, yeah? When you talk about meshes, the first vertices is not the same in all the meshes, yeah? And that's where PyTorch actually comes into play, yeah? And for me, this will be like, something that I'm also doing with my students at FIU. We are looking at this kind of 3D objects and how you use, in a way, this kind of networks, even Pix2Pix or CycleGAN or StyleGAN. And instead of asking the network to look at an image, you're looking at an image that describes a 3D, for example, yeah? And describes a 3D meaning X, Y, Z representing vertices, yeah. So like that, you can really speculate and really play with that. For example, there is a research paper, and I'll have to share this paper because I'm keep repeating this paper all the time. But there is this kind of idea: are the machines actually seeing numbers, or do they see numbers the way that we see numbers, or they see something else? Yeah. And this is only because there was a machine that was was looking at an image that was noisy, and it was saying that that's a 1, and the same machine was looking at the image that was looking like a 1 and was saying that that's a 1, yeah? And then the entire discussion was, is the machine actually wrong, or we as humans, we cannot see the number 1 in that pixelated image, yeah? And in the end, the idea is that the machine is not really looking at the image the way we look at it, yeah, like visually understanding something. It's mostly the relations between pixels, yeah, that are understood. So based on that premise, then for me, it's easy to draw and to say, to draw the conclusion and say, okay, it's enough to input any kind of pattern that has a certain relation and has a certain structure, and the machine should be able to understand that, yeah, without me visually being able to understand it, yeah. So I can convert any kind of geometry into a sort of image, and if I show that to a network, for example, or at least this kind of networks that are image-based, they should be able to predict correctly things, yeah. So probably that's something that you can play with. If you are interested mostly in mapping, then probably it will be interesting to extract the mapping information of the image, of the object, sorry, and then somehow play with that information, yeah? Because right now the mapping that you have, it's kind of, almost like a collage. You just apply something on an object. So probably it will be interesting to say, okay, I'm aware of the UV space of the mesh, of the geometry, and I'm using that information somehow to train an AI and then bring that information in back, So I think those kind of plays will be super interesting, yeah. So you can create super interesting things without even going into, the architecture of the network, just by, being smart about the way that you are playing with the data set, yeah. Okay.
All right, thank you very much.
Matthias, did you want to chip in there? I mean, you've had experience of working with PyTorch 3D on an actual project.
Yeah, sorry. So actually, Daniel pointed out an important aspect of that, which is, you know, an image, it consists of pixels and the model has faces, points and lines, and you have to figure out how, I mean, on the one side, the difficulty is in labeling something like that, like specify what's a wall, what's a ceiling and so on, so that it understands semantically what that object actually is looking at. Or what we did was we just ignored that and just created a database from scratch that was labeled as houses. So just trying to figure, you know, trying to capture, you know, that information in a model is possible. It's a longer story. I don't want to bore you with that, but basically it's about what Daniel really pointed out already, which is you have to create your databases first before you're actually able to generate anything with PyTorch 3D that makes sense. And you have to train it accordingly. So there's like all these steps that you go in between to get it there. We're still working on that database. We've been working on that since, I think, late April, early May, something like that. And we don't have enough models to really train it properly. So it's just a matter of, you know, getting the training done. But I actually applaud the students and Mateos for working with that and successfully running already like a couple of examples with that. I think that's super exciting. I'm really looking forward to that. Also, thanks for the shout out to Sofia Crespo. I think she's an awesome artist. Just as a side note, her 3D models of these kind of weird insects, she basically models those in 3D first, quite conventional, and then runs a 2D to 3D style transfer on top of them to deform them.
Yeah,
thank you.
That's I guess that's kind of a bit like what Guven Chozo has been doing at UCLA. Kind of it's not really 3D, but it's kind of mapping onto a 3D form. I just wanted to say one other thing, just in terms of neuroscience, and I've just had a conversation with Anil Seth online, and I'm hoping he's going to come in to join the neuroscience session on Sunday of next week, so it's 8 days time. And one of the comments I was saying to him was that the problem, because I don't know if you've seen his TED talk where he uses Deep Dream to try and model what predictive perception is. And he kind of, you know, he talks about perception as being a form of controlled hallucination. Now, the problem about Deep Dream is it's not controlled. And I was saying, well, what about using a GAN? Because then you've got a kind of discriminator and you've got to, you can actually control it in some way. And it was kind of like a naive question because you've got to be very careful with neuroscientists. But he said, absolutely, they're kind of working on something similar at the moment with a discriminator and a generator. So it's kind of interesting how GANs or something similar to GANs begins to feed into kind of understandings of neuroscience, which I think is absolutely amazing. And I go back to this kind of thing I was trying to raise the other day, that in the end, neuroscientists and AI people are often looking at the same thing. And it's kind of there's an overlap of kind of they're looking for just simply intelligence and trying to use computational models to understand how the mind works. And it's producing some astonishing comments and things, astonishing results. I don't know.
Just a few other comments here regarding the GANs and Mateo's project. I think you also have to, or we have to be very careful to understand exactly what the networks are doing. And this is very similar to what Neil is saying, you know, how you control that hallucination. Yeah. So then it's really a matter of really understanding, okay, I showed you like three types of networks, which are, okay, right now, let's say they are just almost like a milestone in the GAN family. There are multiple others in between, yeah, for sure. But it's just important to understand what each one is doing and what kind of task you can apply each one for, yeah, and then how I can combine maybe certain ones, yeah. Just a second, sorry.
I don't know whether Wanyu wants to kind of say anything. Or you're here, Wanyu. It's great to have somebody with such experience watching this. Or indeed anybody else while we're just waiting for Daniel to come back.
My apologies for that.
Okay.
Okay, I'm back. So what I was saying is like, we have to really be careful, like the types of network that we are working with and what kind of task we can apply them to. For me personally, I find CycleGAN to be the most innovative when it comes to creativity. Like I think CycleGAN is able to create something that resembles a more creative process than StyleGAN, for example, or Pixel. Yeah, a StyleGAN, for example, is just learning to interpolate. Let's say, yeah, like you give a bunch of samples, examples, yeah, and then it's able to learn the representation of those samples. Yeah, a CycleGAN is able to go outside of whatever you are giving. Yeah, it's able to generate things that are outside of that. Yeah, so I think we have to understand that each one, what kind of task it can be applied for. Yeah. And then the Pix-to-Pix, how I can control maybe even more certain things, So I think from that perspective, yeah, it's very important and for us to understand and see, okay, for this specific task, I'm going to apply this, for this one, this kind of network and so on.
Okay, let's move on. If there's any further comments from anyone? Elijah, you'd like to present?
Hello. Yeah, I can present next. Can you guys hear me? Okay. That's very hard to follow up. I'm gonna try to do my best. Okay. Okay, so after the last week's workshop, I have been focusing a lot on truly trying to understand exactly those differences. Like Daniel just mentioned, I was fascinated by StyleGANs because of the beautiful results it produced, but I didn't feel that it was very controlled and that I could create many new things. So I started recently to try to really understand how I could use CycleGAN to create some of the videos like you guys shared last week, and I'm still working on that. But first, the first attempt I had was at following step by step what Daniel showed us with the Barcelona satellite to labels and understanding the new kind of results that it was creating and how the machine was learning from that input. And my next step today was looking now at if I have pictures moving a blanket or changing the texture, how that can change landscape. And that's something I want to keep doing moving forward. I'm actually still training the CycleGAN's model because I loaded about 1,000 photos. It was 1,000 frames, so it's still loading as of right now. But I also did a couple of experiments with StyleGAN. So the first one was what Daniel showed us in lecture, and it was using the satellite images of mountains. And then moving forward, I tried images of paintings. And finally, I tried different satellite areas in the world, such as San Francisco Bay South Ponds. And I have a video to showcase the results of these StyleGANs. So, share screen.
All right. I think he also did a lot of great work. I mean, for just 1 week, it's a lot of work there. I'll just have a few comments the improvements or how you can look in a way at this kind of networks and probably improve even more the results. So first will be the CycleGAN example that you showed with the blanket and with the landscape. So you have to also have to understand a bit this idea of what kind of information I have to show to the network and what kind of output I might get. Yeah, for example, if I have a data set with a satellite image of a city, and I have a blanket image, yeah. So the expectation will be that somehow the network is going to understand the composition of the blanket and then impose that kind of composition on a city or something, yeah. So in that sense, then, you know, that conversion or that translation that I'm trying to apply, it's actually more interesting because I might end up with, you know, interesting configurations of a city or something, or I can say that I can control the composition, you know, while still retaining the way those kind of local rules that you have in a city. If you just apply it like blanket with the landscape, mostly you are just performing a sort of almost like stylistic in a way translation where you're just copying in a way the style of the blanket and transpose it in a way on the landscape, yeah. So in that sense, in a way, try to look at it from that kind of perspective, yeah, like where exactly, which is the highest potential that this network can provide for me. Like if I'm using it to copy in a way or transfer composition, probably it's more interesting than just a mere texture. And then also with the StyleGAN videos, I think they're all super cool and very beautiful, all of them. But for you, in a way, to be able to get to control better the results, will be good for you to always have the video and then what kind of parameters, yeah, you used, and try in a way to understand in a way that relation between the output and what parameters you're using. And I'm talking here about truncation or other kind of, you know, parameters that we have there, because in that way, then you can really, in a way, almost like choreograph, let's say, the movie and try to play with it that way. And then also don't shy away from connecting some of the networks. So for example, you have the StyleGAN generating something, and then you have the CycleGAN maybe interpreting that thing and translating, you know, and then that result maybe goes into a StyleGAN again, you know. So those kind of things could be also very, very interesting. And it's almost like to say that it's not anymore the, you know, the data set, because usually we are saying, you know, that AI is just learning whatever we are giving. And if we give a lot of images of a building, then the AI is just generating those kind of buildings, yeah. But maybe this will be almost like the third, fourth, fifth generation, almost like, you know, like where you have an AI first generation will be I'm just learning from the data set that you input with real images of buildings. Then the second generation will be I'm basing my learning on the previous network, and then the third one, you know, something like that. And then suddenly you might end up with a kind of result where you actually say that actually the AI learned it has its own, let's say, history and its own experience, and based on that, in a way, it's trying to generate something. Yeah. Because otherwise, it's always going to be bounded to the data set that you input. Yeah, if you input like biased data, and bias here can represent everything. Yeah, like from aesthetical preference or something else, it's just going to output those kind of aesthetical preferences, but it's going to have a hard time to output something completely outside of those biases, let's say, yeah. So I think one way to go about it is just to try to chain them or create almost like experiences, yeah. So it's almost like right now we are almost like we as humans, we have our first experience, we design, and then we output. So the same thing happens with the network right now. It has the first experience, let's say, with the set of the images, and it's just giving an output. But in our case, we have multiple of these kind of experiences. Yeah, we go through these kind of cycles of, you know, designing and understanding design, and then designing again, and so on. Yeah, and probably that will be something that leads to something super creative, I would say. Okay.
Thank you so much for the feedback.
Just one question. What would be the next step? What are you envisaging as the next step for this?
I think taking consideration what Daniel said, moving forward with the CycleGAN would be, perhaps selecting a better data set and really developing that. And then as far as the StyleGAN, really running variations with different truncations and different settings and registering which settings I'm doing for each thing that I'm running. So I have that kind of database for myself moving forward. If I'm doing a specific video, specific variation, which settings are the best for each scenario. So definitely really appreciate the comments and look forward to move forward with this.
Okay, great. Any further comments?
Thank you.
Nico, I said your tech. Would you like to go next? Difficult to follow on from both of those, but I'm sure you can manage.
Yes, I could go next. Here, let me share.
I think while Nico is sharing, I think we have to think of these tools and also AI, not necessarily as just one algorithm, because AI is not necessarily just one algorithm. Probably a series of algorithms will create something that we are really going to consider, creative or super interesting, So we should, in a way, when we work with this, probably we should stray away from this idea that I'm just going to have one algorithm and then that algorithm is creating for me architecture or something. I don't think it's the case.
I apologize. Needed a quiet for a moment. Yes, I'm sorry about that. Yes, so I've been trying to develop a little bit more on the process rather than trying to maybe try to make something or just try to combine things. So I guess I'll explain a little bit on the process as well and show the type of results that I'm getting from it. So to go over what I'm exactly trying to achieve is that I'm trying to initially start with the analysis of these sketches developed by Tom Main. And I'm very interested in these sketches, especially in how they drive his conceptual process in terms of how he creates these abstract sketches and then starts to rationalize them into architectural schemes to then develop his actual buildings in the pursuit of trying to create non-referential architecture that finds itself to be more original in its own plane of existence. So, but I wanted to achieve this in a way that I can develop using the GANs to augment basic gestural sketches. So I looked also in sketches by, Starchitects too. These are the gestural sketches of Zaha Hadid and also Wolf Pricks, a few of them. And so in their case, they start with these more simplistic gestures rather than these complicated abstract sketches to then dictate the design of the building itself. So my intent with the original set was to try to get that initial sketch of intent where it's a more simplistic sketch and tries to inform a certain scheme, and then augment the sketch with a series of the Tom Main paintings as the data set, and then move on forward from there to where you would be able to take that output and have an analysis on top of it for architectural rationalization to further develop the concept. So what came out of that is that I eventually ran those for up to 5,000 epochs. These are the sequence of initiation. First one was 200, then 400, then I made a jump to 5,000. The issue I eventually found with this was that certain types of paintings were identified with certain schemes, because this initial one had a very low data set, but it started to produce results like this, where it was identifying the main shape and the gestures. But I think I needed to develop further on the data set. This one is actually, so I eventually after that, I want to go to the StyleGANs. So this was like the series of the face started with the models, and those were the series of the sketches on top. but it wasn't going as far. I couldn't get to the end of the StyleGANs. It just started like bleaching out the paintings. So I'm going to try to see if I can revisit that, because I do want to create more of a sequence of using them. But eventually I tried to change the way I was thinking about it. So instead of just trying to take that initial sketch and then run it through the combination of it, I tried to split the individual types of schematic sketches to run different filters on it, so that maybe I can run an initial sketch, have 4 networks trained to output 4 different results that could be lined up side by side and compared. And then from there, it would be a selection process with the analysis for the concept development. And those will be organized based on types of colors, so they can be grouped, categorized to create more data sets. So this would be like one data set, that would be another data set, and then this one could be this data set. And so I started working from this type of data set over here, that because it takes quite a while, I didn't get as far as I would want to. This is at 200 epochs, but I need to definitely go more into the thousands, but the CycleGAN is it's not there as of yet. But I'm hoping from here to try to see how far I can take the CycleGAN, and I'm going to try to revisit the StyleGAN as well, because in the end I really want to try to get the reason why I went with the faces or with the sketches for the StyleGAN is that I really wanted to try to create a StyleGAN with an interpolated video in the end, so then I can run maybe like a video with 2 videos of sketches and 2 StyleGANs of sketches and a StyleGAN of the paintings, and then try to run those with the CycleGAN and see if I can get a video that matches or tries to create that connection between the paired data, so that eventually I can have a system that I can create a sketch, feed it into the system, and then it would give me that filtered the GAN's vision on top overlaid to give it new information for analysis for architectural conceptualization. So that's where it is right now.
That's
I'd
great
like to be
work.
further along, but that's where it is.
That's great. That's great work either way. I think for 1 week it's still great work. How many samples do you have right now of domain sketches?
Well, I took originally I had about, well, the original samples themselves, I had about like 26. Some were very low resolution, so I had to clean them up. I only went to the high resolution ones now. I have the orange samples, if I share them back so I can show them over here. So so for these samples, I have basically these 3. These are 1024, and then these are also 1024. But I tried to use the augmenter, and like out of these, I was able to develop 100 samples. So the ones that I currently had training was I had 100 of these and 100 of the sketches, where you can see it over here. These were basically a series of 17 sketches, and I augmented to turn into 100. And those are the ones that I was running into this to the CycleGAN.
Okay, so I think here you need more for sure. You need more image, more data, a bigger data set, yeah, for the CycleGAN. And I don't know if there is a way for you to be able to get in contact with Domain to have more of those images, and probably that would be also a good thing, because it's also a question of probably copyright or something. If we are allowed, like, or yeah, if we are allowed to use this kind of, you know, work from Domain, you know, to have AI generating something. So probably that will be also a safe bet to say, okay, I'm also having a larger data set because I get in contact with Domain, and maybe I can get more of those images. And at the same time, you also solve this thing with the copyright, yeah. But I think right now, yes, that's the main thing. And in your case, you really need a larger data set, yeah. And how you can go about it, probably you can start first to generate your data sets with the StyleGAN. And then once you have the StyleGAN learning the representation of your data sets, then you use those data sets for CycleGAN, yeah. I would say CycleGAN, you need to go above 1,500. I know that the research paper, the original CycleGAN, they are saying that they use something like 200, 400 images. Personally, all my experiments that I ran with CycleGAN, they have to go above 1,500, 2,000, or 3,000, something like that, to really have some quality results. Otherwise, if you just keep 200, 400, I don't really think that is working that well. So in that instance, for example, then you really have to maybe you have, let's say, 100, 200 images of Tom Main's sketches, yeah, and then you can augment them a bit to 500 to 1,000, let's say. But then those, you use them in a StyleGAN, and the StyleGAN will just learn the representation, yeah, the underlying representation of those images, and then afterwards you can generate as many, you know, samples as you want, yeah, for the CycleGAN, you know. And it's almost like those samples that you're going to generate, it's almost like they are a sort of augmentation. I mean, you can use, yeah, StyleGAN as a sort of augmentation technique, yeah. So like that, you know, in a way, you have results that are resembling more or less the same, but they are slightly, in a way, you know, stretched or something, yeah, or yeah, slightly different. Yeah, so that will be my advice there. You have to figure out a way to make those StyleGANs work, and also not StyleGANs, sorry, CycleGANs, and also the resolution of it. Right now, I think you were saying you ran it for 5,000 epochs. That's a lot.
Yes,
yeah.
Those were at 256 by 256, a very low resolution
So,
to get them
yeah,
that high.
so then it's meaningless if you run it at 5,000. Yeah, I have a network that ran for 900 epochs, and the results are just extremely beautiful, you know. So yours right now, they're not even getting close to that. So I think it's a matter of resolution. Yeah, you can, and you have to understand that yes, you as a human, you are able to look at 256, and, you know, see the beauty in the image. But the network, like I said, is looking at relations. The less pixels you have, less relations you have. Yeah, so less is going to be able to understand certain things. So then, if you go with the resolution above 512, I think then you'll start to have some interesting results. Yeah.
Yes, I guess that'd be the hurdle, because so far I have like 30 of the images, but only 6 of them are 1024 by 1024, and
yeah,
that's the problem with the. So I'll try to see
yeah,
how
so
I can
you're
go
going
around
to
that.
probably on Collab, you're going to be able to run just 512 or 600 resolution probably. You need a 24 gigs graphic card to be able to run 740, for example. But on a CycleGAN, you're not going to be able to run it 1024 for sure. You know.
Okay.
But it still is good to run or to have the data set 1024, and then when you load it into the network, you load it at a low resolution. Yeah, it's better than to just have the images straight out like low resolution.
I see.
Nico, I think we can I'll try and put you in touch with the office. I mean, there was an exercise that was done by, I forget his name, Daniel Pruska or something like that. It was and it was just straightforward grasshopper, right? But there was kind of mutations in a theme, and they have 100 different variations that were produced. And this blew Tom Main away. What I actually, it was almost identical. This was almost 12 months ago. I went around to the office to go and talk about all these things, and I mean, Tom takes the view that grasshopper is a kind of early form, low, good old-fashioned AI kind of thing in some senses, but it's not really very advanced. And when I was showing him the sort of work that was coming out from the studio this time last year, he was kind of scratching his head and saying, what do I do with that? Because I can't control it. You know, and the real problem about StyleGANs is really for someone like Tom Main, who starts off the other way around with this kind of inspirational sketches, is he's kind of controlling it all along. And the issue of control becomes central for him. But I'll try and set something up, and we'll see what we can do with that. So yeah.
Yeah, I guess even if just an email, hopefully, if he takes a read on it. I'm sure he's a very busy guy, but hopefully I can get him interested in this type of research.
Yeah, absolutely. He is interested in that. I mean, absolutely. I mean, we saw this debate between Wolf and Tom, but I'll go through someone else who's not directly through Tom himself to introduce things. So let's see what can happen.
And I think that will be an amazing, you know, like also for you, Nico, as a master student. Yeah, it's going to be an amazing, you know, opportunity to get in contact, you know, with these kind of offices. I think that.
Yes, that'd be very huge. I'd really appreciate that, and I'll put my gratitude forward for you, Professor Leach, if you can get me in contact.
I can't guarantee anything else because I know.
Sorry, Neil. Now we have to do it.
He's laying off people in the office. I know a few people, my context, I no longer have jobs there. So, but anyway, no, we'll see. But I mean, Tom is incredibly generous as an individual, as a personality. I mean, as a teacher, he is. I mean, the reports back from the students, they can't believe this guy running a kind of Pritzker Prize-winning office is so generous with his time. But let's see what we can do. Any kind of further comments? If not, Ivo, do you want to get ready to present? And could someone volunteer to go after Ivo? Ivo?
Yeah, I got you. Let me share my screen here. Okay. All right. Can you see that?
Yeah. StyleGAN.
Okay. Yeah, exactly. So my idea was to combine simple geometric architectural features with organic landscapes. In order for the machine to dream up or hallucinate a distorted / organic version of Louis Barragan's architecture, I specifically chose simple architectural forms in order to get a clear sense of what the AI is actually doing. And I trained 500 images through StyleGAN, which translated natural landscapes into images that mimicked Louis Barragan's buildings. So these are some of the images. And here is my video. Yeah. So yeah, that's what I got.
How many epochs was that? Did you say? Sorry, missed out.
No, I didn't. I don't have that. Not sure. It took 4 hours.
Okay, so how many images do you have in your data set?
500.
Okay, so you'll have to go above that. Yeah, so I will just improve in this regard. So more than 500. Yeah, and then
Okay.
I'll train more than just 4 hours. Yeah, so this one will have to train more for you to really see some positive results. And then also I'll really check back the quality of the data set. Yeah, so right now you see that the kind of results that you get here, they are not very detailed. They are not really giving you that much information. And I have a feeling that you just have a few, like 4, 5, or 10 maximum images, and then you try to augment them out like to 500 or something. Yeah. And I think that's, in a way, you don't have a lot of information that, that the network can learn. And probably you have to expand on that. Yeah, you have to really look at that specific type of architecture and really, find more samples. And let's say you have 200, 250 examples of that specific building or that kind of Louis Barragan, in a way, architecture. And then you can go on and probably augment. Yeah. So usually also with augmentation, I will say you have to be careful. Like, we cannot augment our way out here. You can have, let's say, a sort of ratio of 1 to 4, let's say 1 image original, 4 augmented or something like that, or maximum 5 or something like that. But if you go very high out there, probably you're not really helping at all, the process. And this depends, this kind of what I'm saying now with 4 or 5 depends now, of course, on the type of data sets or the type of task that you're trying to train. For example, if I have a network that has to identify a chair, like object recognition, then yeah, probably I can make it multiply by 8, one real and 8 in a way augmented images of that. Yeah, because I can have rotations, 90 degrees, flip, left, right, top, bottom, and rotate, mirror, and so on. Yeah, there are multiple of those that I can do. But here, I think right now the network doesn't have enough information when it comes to the semantic information that's represented in the images, to actually be able to learn. So I think that's where you have to put your focus on. try to really develop like a very large 250, something like that, let's say, data set with images of this StyleGAN, yeah. And then you can maybe augment that 2 or 3 times, yeah, that amount.
Okay. I'll make a note of that.
And yeah, like I was saying, then also the training has to be longer, yeah.
For sure.
The longer you allow it, of course, some networks, they will just collapse, they will just fail, yeah. But usually, you should leave it like run, even if you have this kind of transfer learning that it's already incorporated in the script that I share with you. So that cuts in a way the training time from a few months, is cutting it to just a few days. But still, I will allow the network to train for about 2 days or something, 2 to 3 days, to really have some very good results.
Okay, perfect. Thank you.
Okay, we don't have anyone lined up to go next. Who would like to go next?
I guess I can show.
Okay.
It's nothing like the people before.
Don't worry about that.
Okay, so I was like literally just playing with it, seeing, like, understanding it, writing down like all the steps, making sure that I'm understanding this. So this is just like me playing around with it. For CycleGAN, I got it up to like 80 epochs. So I went for a really long time, but unfortunately, these are the fake images that I'm just showing. Unfortunately, I came across an error, which was I tried like solving.
Are you sharing your screen? I think we are still seeing Ivo's screen right now.
Ivo, could you unshare?
Okay, cool, nice. You're right. Okay. Okay, so then, thank you. So then started off with CycleGAN, let it like go up to like 80 epochs. These are only the fakes. Unfortunately, I ran into this problem. I ran into a problem before that, but got some help from my classmates. And then I wasn't gonna like keep like spending my time on this, so I'm gonna fix it later. But that's where I ended with CycleGAN. And then I started StyleGAN, and I wasn't really sure what I wanted to do. This has nothing to really do with my thesis as of right now, but it was just testing to see if I can get through all the steps. So you were doing satellite images of mountains. I decided to do kind of like elevations or top views of mountains. I let this run for 10 hours. My computer, I couldn't believe it, is really fast. So this is 10 hours. I know that if I spent longer on it, it could come out better. These were just a few images that StyleGAN created. And then I'm gonna share 2 of the videos I was just playing around with. You can see, right? Okay, and then that's one, and then the other one is this one. Where is it? Sorry, my computer's dying real quick. Okay, and that one. I realized with a few of the pictures I should have taken, I don't really know, like I'm still testing everything. Obviously there's a little bit of blue there just because of the sky. Maybe next time like I'll crop it differently. I don't know. That's what I have. And then I started doing my own experiments, but the resolution of the images came out really bad. So I can tell what it is, but the pixel is just very tiny. So I need to redo that. But that's what I have.
Okay, so your CycleGAN experiments, I think they are looking very nice, and it's creating very interesting structure just based on those kind of labels. And the funny thing, you see that the funny things, what I was showing in the workshop, the intention was to look at the satellite image and create the labeling on it, yeah. And right now, actually, all of you that you're showing images with Barcelona, you're showing exactly the other direction, from a label to a satellite image of Barcelona. But even that thing is very interesting, because it's almost like what you were drawing then in Grasshopper, you just draw the structure of the city, let's say, and then you just ask the network to translate that kind of information. Yeah. When it comes to StyleGAN, I think you have a similar challenge with Evo, where I don't think you have the data set very robust at the moment. And that's why, in a way, the result, they are very, very cloudy in a way. They don't show a lot of detail and precision. So if you remember the data set that I showed during the workshop, for me, it just took something like 1 hour or something like that. So I just like using Google Earth, and I have this huge screen at home, 4K screen that I can just take screenshots, yeah, like that. And then once I take the screenshot, I have high resolution images, yeah. And then I think I just saved something like 4 or 5 of those images, and then I just started to crop them. But I started to crop in a way an image that is very high resolution in the end, yeah. So like that, I was able to go to 2000, for example, 2000 samples in my data set, yeah. So I think in your case, the same thing is like you have to find like high resolution images if you want to crop and augment like that, and then build up a data set that is quite robust, yeah. And you saw that, I mean, the results, the example that I showed in class last time were super stunning, yeah. And just, I just waited something like, I don't know, 7 hours, 8 hours or something like that. And you see, mostly has to do with the data set, how high quality the data set is. And then of course, okay, if the network is able to learn from the amount that you have, yeah, like the size of the data set.
Thank you.
So yeah, in those size, I would say that's where you have to focus to really have the networks in a way output.
Sorry. I had the 4 images, and I mean the resolution was really high. It was like 1,000 something by 1,000 something. I guess it's not, but I do need more images than that. guess I was just having a hard time finding like a good website, but it's still.
Yeah, so high resolution, personally, I'll call like from 4,000 up, something like that, 4,000 by something, because that will really allow you to have crops around and so on. Yeah.
Perfect. Thank you.
Thanks, Maria. I mean, well done. I mean, you had a go, and it's all about your work. It's about dreaming, okay, at some point. So Roxana, Christopher, and then Nicole.
Sure.
About dreaming, if you think about dreaming is super interesting, because we always, or maybe we think of dreaming as something that it's fixed, when actually I dreamt something like last night, but today when I start to interpret the dream, suddenly the dream, it's getting a different shape, or gets a different shape, yeah. So suddenly the dream is changing while I'm talking about it or something, yeah. It's not the same dream that I had, it's a dream, the interpretation of the dream or something, So it's almost like I'm hallucinating my own dream in the end.
It sounds like a StyleGAN. It's just carrying on. Okay, Roxana.
Yeah, let me share my screen. Okay, basically, I concentrated in StyleGANs. After watching everything, I decided like this is going to be more technologically on my capabilities that I could go into. I tried to do the mountains, and I had some glitches also with the CycleGANs. But like I started getting like my data set, like I tried to do like maybe about 50, 60 pictures that I found of forests. And these were like some of the results that I got here on the left side. And what I really liked was the textures actually that I got from some of the pictures. And then I guess I'll run the interpolated video. And that's it. Can you hear me?
Yes.
Oh, okay. Okay.
So the first results, those were CycleGANs or
No, I did StyleGANs.
the ones that you had in PDF?
Yeah, like these are some of the data set. I still have like, I have a
Okay,
big
I
one
see.
here, but I just introduced like a little bit of them. Where am I?
Yeah, so I think in your
Yeah.
case, it's a good example of yeah, the data set that you have. It's a bit more homogeneous, and that's why, in a way, the StyleGAN it's able to create the interpolations better. Yeah. So if you use Augmenter, probably were you using Augmenter here? Or?
Yeah, I got 2,200 pictures out of the first ones that I put in, and then I run the data set based on that.
I'm just wondering if I'll be curious in a way to see the actual data set, because I see, for example, this frame that you have right now in the video, you see that it's a bit very cloudy, like blurry somehow. It's not very defined, and I'm just wondering if that kind of image is not well represented in your data set, yeah? Because then we can use Augmenter and we can augment and crop and do whatever we do with Augmenter with images, but still it's not going to be enough in a way.
Yeah, I haven't.
And also we haven't talked about this, but it's also a good idea to try to balance in a way. Let's say if you have this type of forest, the one that's more green, and then you have the other one that's more orange. Maybe you want to have, let's say, 200 examples of green, 200 examples of orange, 200 examples of something else. Yeah. So almost like to balance, let's say, because otherwise what could happen is that there is going to be a strong bias towards the forest that has the most images in the data set. Yeah.
Yeah, they're all here. Like you ranged. I try to do a range of pictures of colors to see if I think the orange probably is like lower down and.
Yeah, so we can also look at it like that. Yeah. So if you really have this kind of specific like kind of scenarios of forest, then you can have like you use Augmenter just on one image. Yeah. You take one image and you create augmentations, like let's say 200 augmentations from one image, and then you take the other one 200, the other one 200, and afterwards you put everything together. Yeah. But like that, at least you'll have things that are a bit more balanced, you know. Otherwise, we just have one that is overpowering all the other ones, you know. So
yeah, that's what I figured. Okay, great.
I mean,
this
is the easiest way without introducing other. Usually, these are like a data set topology in a way it's called. They have like you have to understand how the data set is distributed, and there are ways in a way to display the data set. Yeah, like for example, you can look at every single image, understand it as an image, as a composition, as a as content, and then try to figure out how that sits together with the rest of the images that you have in your data set. Yeah. And if you have, for example, a data set that is very scattered, then probably that's going to be something more difficult for network to learn. Yeah. If you have it more homogeneous, probably it's much easier. Yeah. So without going in those kind of topics, yeah, we can control maybe the data set in this kind of way where we are aware of we should be careful and have just this amount of, images for this type, this amount for this type, this amount for this type. Yeah.
Okay.
Okay.
Perfect. Thank you so much.
You're welcome.
So Christopher, do you want to go next?
Yeah, I can go. Can you guys see my screen?
Yeah.
Okay. So one of the things that I fell in love with the workshop and me learning how to use the GAN was kind of the process behind it is very process driven. So the way I laid out my presentation was just kind of going through that process. So it first started off with CycleGAN with the Barcelona dataset. And here I'm showing the first epoch. As you can see, the fakes and the reals. And the way I kind of structured it is that to show you the first epoch, and then I got up to 200. So I'm showing like the start point, the mid, and the end. So that's what it looked like during 100. And this is what it looked like on its last one on 200. It stopped after 200. I'm not sure if it was supposed to do that or, but yeah. And this is just a video where I stitched together all of the fakes from start to finish. And then it just loops at a certain point. So I'm just showing some of my favorite ones, kind of showing how different it could interpret the city and how streets can turn into these huge landscapes. I thought that was really interesting, and how it almost starts to distort the grid and kind of like curve it in Epoch 182. I like that. So then I went into StyleGAN with the data set of the mountains that Daniel gave to us. So it started off with the faces, and then midway it started to finally learn and understand how to get trained to produce the mountains. And then this was the last one. It was a snapshot 303, the network. And for some reason, this video, it might play. I'm not sure if you guys can see it, but it's just basically the start to finish from that training that I did. And these are my favorite seeds from that set. I think they're really beautiful. And then I just started to run the truncations and the interpolations on them. This was one of the ways that I blended two seeds that I really found interesting. And this is another truncation. Well, it's a truncation 0.95, but it's an interpolate radius. And then the more I started to look at these and what I was starting to generate, I started to think about what I wanted to produce out of it. And I started to think about one of my favorite painters. His name is Jackson Pollock. And I'll show you now. But this was the last interpolate that I produced from that data set. So I thought it'd be it would be a good idea to transfer that training from the mountains to Jackson Pollock's work. And it started off again like with the mountains, and then midway it finally started to understand how to paint like Jackson Pollock. And it's funny, Jackson Pollock died in 1957, and it's almost as if he came back to life. Oh, I don't think that one played, but that's okay. So these are my favorite seeds. Really starting to look like a painting. I think it was a good outcome. And then these are just the truncation traversals that were produced. This was a blended seed example. On the left was seed 443-14052 and the other one. And then in the middle is the blended. And this was just another interpolate radio from that Jackson Pollock set. These are linear interpolates. So I'm not sure how much different that I was noticing that some of these were starting to look very similar, and I wanted to know how I would maybe be able to change that, or maybe it's that because I need to train it more. I'm not really sure, but I think this is the last one that I produced.
Cool. Thank you, Christopher. I think you had a lot of fun.
Yeah.
Or I hope. I mean, it has to be fun. Otherwise, if you don't have fun, don't do it.
Yeah.
So I think you had a lot of fun, and I think that shows in a way you tried a lot of things, a lot of experiments, and I think it's also a good approach to, okay, I trained the network, and I think you understood the concept of, once you have a network trained, you can use that network and start from there on, yeah, the other data set, yeah, so similar what you did with the paintings, yeah. Here right now, mostly you're working with the StyleGAN, yeah. So you were showing at the beginning some results from the CycleGAN. So the reason why the CycleGAN stopped, it has in a way a not learning rate. It has in a way a mechanism in a way to reduce in a way the number of iteration that you have. So for example, I think it's called, if you type in the line of code where you have Python train.py, if you type in something like / and ITTER, and then you put in a higher value there, then probably it's going to continue more, yeah. So it's mostly about an optimizer that you have in the network, yeah, and that optimizer starts from a certain value, and then after 100 epochs, it starts to decrease, yeah. And once it starts to decrease and it gets to 0, when it gets to 0, then the epoch stops, yeah, or the training stops, yeah. So that's why you just have to change there a small parameter or argument into that line there, yeah. So it's ITTER, and I think then you just put I think if you put 400, I think that's going to increase, yeah. When it comes to interpolation, so right now if you look at linear interpolation or just interpolation or linear W walk, those are pretty much similar, only because you're still dealing with the linear interpolation, yeah. Mm-hmm. So if you compare the circular with the linear, then you'll see a bigger difference, yeah. And mostly because what you're doing there is just, you're just walking from one to another, more or less, yeah, in a linear manner, versus the other one, it's circles around, yeah. So if you want to go into actually changing that, it's mostly you have to go into the code and change stuff, yeah, how exactly the interpolation happens, yeah, if it's a linear or not, yeah. I think there was also another option there, I think in the script that I share with you, that allows you also for a more noisy interpolation. It's still linear, but it's a bit more noisy, yeah. It's almost like jumping along a curve, yeah. So you have a curve and almost, yeah, you have a sort of offset, and within that kind of offset, you have a random noisy in a way interpolation, yeah. Mostly when it comes to interpolations and stuff, and latent space walk, it's something that you have access to just code, yeah, if you type it in, yeah, coding. But yeah, right now the ones that I share with you, I think they just have these two modes, like linear or circular. So, but what you can try to do is like to explore a bit more. I think you have those kind of options of the radius of the circular interpolation, and then you have also the truncation values or other kind of parameters, yeah.
Perfect, thank you.
Yeah, you had fun. I mean, I think Jackson Pollock was having fun too. I mean, he's one of his crazies. Okay, so we got Nicole, Mario, Adriana. Yeah, Nicole.
Okay. So I was using StyleGAN, and I was using as my base. Hang on, I'm trying to find my video to share the screen. Okay, and I used like wasp nest and bee's nest. If you have a fear of holes, I feel like you shouldn't watch it because I forgot it's like what phobia that is. So that's just like your pre-warning here. So
my diploma was the same, and everyone was making this kind of jokes and comments about my diploma.
Okay, so this is I made a few videos, and this is my second favorite. And then this one is the one I liked the best. Oops.
No, I think it's the same one. You might have to unshare it and try again.
What did you say? I'm sorry.
We see the same one. You have to unshare it and then share again to get the another video.
Oh, I didn't know that. Okay, sorry. Okay, let's try this again. Okay. I didn't mean to replay it.
What kind of resolution did you use for this, for the StyleGAN?
Honestly, I don't remember. Some of my base files, as I went and through it and was using Augmenter and all that stuff, I think one of them was a pretty low resolution, and I had a couple that were high. Yeah.
Yeah, so I think that's something that needs to be worked on, and try to have images that are good quality, and try to have quite the same images, the same kind of quality, because that's going to like create a lot of noise then in the training, and you'll end up with this kind of like results that sometimes they look very sharp, sometimes they are very noisy in a way. And then I think that kind of play of different scales, I think probably that's also interesting, like to have different cells at different scales. But yeah, I think that's the main concern here now, like the resolution of it. Yeah. Right now, I think the one that I share with you, that pre-trained network, I think it has 512 to 1024 or something like that. Yeah. If you go below that, probably it's going to create some issues. So yeah, I would say that's where you should focus. Yeah, try to build up a data set that it's quite, and probably also saw the range. When you created the video, you saw also the range of your data set. Yeah, probably try to have a data set that is very diverse and that is very anyway high resolution. Okay.
Perfect. Thank you.
Yeah, thanks, Nicole. I'm glad you threw yourself in at this. I mean, it's a foreign territory, but I think you guys have had fun. Okay, so let's go Mario, Adriana, Andre, and then Edgar.
Hello, how's it going? So for my data set, I chose to do our experiment with corals. My data set was around 800 photos. And that took about 17.5 hours. I actually ran it for about 4 hours before this final iteration. and there was an issue. So I was hoping that I could use that network link that you had given us to continue it, but I unfortunately got a couple errors. So I just had to start fresh. But you can see that the faces were definitely changed pretty nicely. And these are just some samples a little bit closer up. Have the videos here. I don't know if you guys can hear audio.
Show the audio, the computer audio.
Oh, do I do it at the top here?
Yeah, I think so. Is it under view options? I'm not sure. We can't hear at the moment, do we?
Maybe it's not here. Oh, I think I had to.
Probably when you share it, you have to.
Yeah. Let me try again. Share sound. There it is. Okay. And I tried it with a second one just to give it another shot. I really tried with like 10, but these were the two that I liked the most. Thank you.
What kind of resolution did you have for the data set?
So the original photos were, I believe, 3840 by 24 or something. They were pretty high resolution, but for some reason they ended up getting a little bit fuzzy.
Yeah, so that's why I was asking, because those kind of blobs in a way that result there in the network, usually they indicate that kind of problem with the data set. So that's why I was asking. So right now you're just randomly cropping, yeah?
Yeah, there's a random crop.
Yeah, I'm just wondering, in a way, probably you should spend some time to look at the data set, at the original images, and try to, in a way, identify if some of those images have information that is not really relevant to this idea of coral, yeah? And maybe just exclude those parts, yeah? It might be that, you have in one side of the image you have coral, and then you have a lot of like sea or something, yeah, water, yeah? And probably that's
So
not really relevant.
I tried to weed those out as best as I could. Like if there was any empty space, I would remove it.
Remove it how? Like cropping?
Just delete it, like remove it from the folder so that it's not in the data set.
Okay.
I tried to get as many with just polyps or, the actual coral as possible.
Mm-hmm. Yeah, because there's something that's strange happening. How many images did you add in the end in the data set? 800
images.
Okay.
And it ran for like 17 and a half hours.
So I'll say try to push them above, yeah? And above 1,000. The ones that I showed last time, I had the data set with 2,000 images, yeah? The one with the satellite images of mountains. So in your case, because you work with corals up and down, it doesn't really matter. It's mostly about the pattern that it's creating. So because of that, you can play quite a lot with the augmentation, like up and down, left and right, and so on. Yeah. So that should allow you to go to 2,000 or even higher than 2,000, yeah, samples. But I think that will really help then. Will really help the training.
So
and then
even
if
you have
another thing that you also can try to do is maybe you look at different types of corals first, yeah, and you learn in a way those types of corals. and afterwards you output a lot of images within that type of corals, and then later you start to combine them. Yeah, and let's say you have let's say you have two types of corals. You have two StyleGAN networks that are training for each type, and they're going to output, let's say, thousands of images, yeah, just for that type, and then you combine those. Yeah, you combine those, and you have them as a data set for a different StyleGAN that is going to look at all of them. Yeah. So in that way, probably you can end up with a very interesting, like, almost like crossbreeding, let's say, between the two types, But I think for something like that to happen, you really need to have like the first type, the second type very well represented. Yeah.
Okay.
Is that making sense?
Yeah, and I heard you mention earlier something about colors. In this case, there was plenty of different colors. Does it really matter? Should I have done maybe like a training for, green and then separately done blue or whatever?
Not necessarily. In your case, the corals, they are so colorful that it's hard to separate things like that. Yeah.
Okay.
But in that instance, for example, you have the same kind of like the content, you are still dealing with trees and leaves and so on. It's just that the color palette, in a way, it's completely different. Yeah, you have a green forest, or you have an orange forest, or yellow forest, or something. So the content was still the same. In your case, I think also the content is changing. Yeah, so you have super colorful, and also the shape of the corals changes and so on. So in that instance, I will not really deal with that. I will just deal with like what exactly you're trying to learn, yeah, or what you're trying to ask the network to learn. So if you're asking certain types, then okay, I'm just going to show those kind of types, yeah. So that's how I look at it.
Great. Looking forward to continue trying it out. Thank you.
Yeah, Mario, congratulations. I think you kind of threw yourself at it and had a go at things, and you've got something out of it. It's great.
It was definitely fun to try it out and get my feet wet. I appreciate it.
Okay, Adriana, then Andre, Edgar, and Julia.
Can you hear me?
Yes.
Okay. So I used Van Gogh paintings, and looking back, I do regret not choosing a more varied color palette, because I think that would have been a little bit more interesting, but oh well.
Sorry for keep repeating Van Gogh during the workshop. I hope I didn't influence you to go with Van Gogh.
No, it's the texture is very interesting, and I wanted to look at what new scenery would be generated through this texture. So these are some of my CycleGAN samples. I put the real next to the fake. The resolution on them is not that good. Also, another thing I would tackle in my next run of this. And it was definitely, the truncation difference was definitely there. It was definitely present. I found that super interesting as well. You can start to see that it starts to make new landscape, and I was just, I really enjoyed this. This is a very fun project to do and work on. These were the these were the StyleGAN seeds that I used for the video, and the video I find super cool because there's a bunch of different landscapes in there. And also, I really enjoyed this, how the circular looked. Let me, yeah. I personally just really enjoyed this.
So you're working also with CycleGAN, yes? The first ones that you showed, yeah?
Yeah.
Okay. So yeah, I think this is a general comment that I'm keep making. I think it's mostly, yeah, mostly all the task is on how we build up data sets and how clean they are and how well representative they are of what we are trying to represent, yeah? The same also in the Van Gogh, for example. Although the StyleGAN results were interesting, yeah, but they were not really necessarily resembling, let's say, Van Gogh, or at least, you will not see that kind of palettes and those kind of textures that normally you'll have in Van Gogh. And probably it just has to do with, the type of images that you fit in, the type of examples from Van Gogh, the resolution of them, like how many you have there. How many did you use right now for the StyleGAN, for example? How many samples, images?
I'm sorry, I don't remember. There was just so many numbers of things.
Okay, so yeah, because probably that's something that plays a big role, yeah. So if you have this kind of like pre-trained, in a way, network like the one that I share with you, and then you just transfer learning from it, and you continue the training from the pre-trained network, then you still need something like 2,000, 3,000 kind of images to really have some very good results. Yeah. Of course, if you go even higher than that, probably you're going to have even better results. But to get towards that threshold where the results, they look very good and they are really representative of the data set that you're presenting, you need to bring it up to something like that. Yeah. So here you see it's exactly the problem that I was describing during the workshop with Van Gogh. Yeah. It's very hard to create Van Gogh. So yeah, there are certain paintings. So how do you create extra new paintings? Yeah. So the idea here, I think, for you will be if you really want to create Van Gogh, and in the end, like have a StyleGAN that really outputs, extreme amount of time will have to be dedicated for finding exactly paintings that are high resolution, and then what's the augmentation strategy, which is the proper cropping of this, yeah. Because it could be that right now you're just cropping very small, yeah, and because of that, then all the results, they are mostly detailed kind of results, yeah. But what if you have a larger crop? Yeah, maybe that one, once you have a larger crop, you're also going to see like some compositional, in a way, learning, let's say, of the network. So the network will output something that deals also with composition, not so much just with texture or texture or style in that kind of sense. Yeah. So I think here you have to play a bit with it. I understand that probably Van Gogh is not that easy to find, like a lot of high resolution images. But if you continue with Van Gogh, yeah, you have to figure out a way that maybe you can look also at super. There are certain networks that allow you to 4x, for example, an image. Yeah? Of course, it's not the most ideal solution, but in case that you don't have any other option to get your hands on a very high quality data set, high resolution data set of Van Gogh, maybe that's an option. Yeah, you have, let's say, images of Van Gogh that are like 512, and then you scale them up 4 times, yeah, and then you are able to crop them or something. Yeah. So if you're looking at super resolution, you'll see that I think there's SRGAN, or how it's called, something like that. I can share it perhaps with Neil, and Neil can share it with everyone. But there are a few networks out there, yeah, that deal just with that, yeah, just increase the resolution of an image, yeah. without, in a way, having this kind of pixels, showing up large then. Okay. But yeah, that's where the focus should be. Okay.
Okay, thank you.
Well done, Adriana. You've had a go. It was great. Andre, Edgar, and Yulia. Someone else I'm missing, I think. I'm trying to think of the name I'm missing.
Okay, share my screen. Are you seeing my presentation?
Yep.
Oh, okay, perfect. So my name is Andre. I'm gonna present to you my GANs explorations. And so I really like the idea or the thought that an AI can hallucinate and create creative outputs. And so this whole idea of hallucination was a large part of Dali and the way that he went about his paintings. So he worked on the principle of the paranoid critical method, which is a mental state in which deep paranoia and anxiety create hallucinations. And then he takes these visions or these hallucinations and then brings them into physical form into his art. And so then he tries to kind of rationalize the irrational. And so in this case, he has very recognizable characteristics, such as the landscape, the sky, the clouds. And so the idea is to take a cumulative set of data that has this type of characteristics and try to tap back into those, I would say, initial hallucinations. And so it's kind of just bringing it back to how would those hallucinations look like. So this is the data set that I created for this specific exercise. And so these are the results or the hallucinations that I got from that specific data set. And there's some recognizable figures and some motifs that are, I guess you could say, very recognizable in his paintings. And so this is a video of interpolation between the different images from this data set that was trained on the initial faces. And so the faces then translated into his paintings or into this hallucination of his paintings. You can see it. There's some problems with the resolution on this one because I didn't really clean up the data set as well as I should have. But then I learned that for the next type of exercise that I want to go into. So really thinking about the hallucinations and how much your environment can affect your subconscious and conscious state. So the idea of Catalonia, which is Barcelona, where Dali is from, I wanted to maybe dive a little bit into the idea of what it could be, or could Dali be an architect? And so it's taking this initial trained set of data that produce these outputs, which are in a way very recognizable, although the ones on the left that were created by the previous data set. And so I used that trained set to then create images from Catalan structures in Barcelona, everywhere from Enric Miralles to Gaudí. So it's a mixture of both contemporary and traditional architecture of Barcelona. And so the results were quite interesting, and you can see where the data is getting driven from. And so these are the outputs that I got. And this one you can see the correlation of kind of like the stilts and the different things that are present in the architecture. And this is kind of an interesting facade that I created. And then perhaps this is my favorite one, and it's taking all the motifs of the clouds and the balconies and the windows, and it's creating kind of an ephemeral building that's almost becoming clouds, like the clouds of the paintings. And so I thought that was really interesting. And this is more variations with different blendings and truncations. And here's the last video. This is just like a blend of all the outputs from that data set. And so, yeah, thank you.
Thank you. So here mostly you're using StyleGAN, yes?
Yeah.
And here you just started to combine in a way DALI with Catalan like architecture.
Yeah.
Is that correct? Okay.
Mm-hmm.
So yeah, here what I will say. Okay, it's interesting as a experiment and probably the same kind of discussion. Like make sure your data set is robust enough. And if you use this kind of DALI and Catalan architecture, probably also try to have similar like amount, let's say 1,000 images Catalan architecture, 1,000 DALI or something, yeah. So that could be one experiment. But another experiment that I'll suggest you to do is also try to look at the CycleGAN, because what I showed with the CycleGAN last class, and we didn't have time to go in more detail, different ways how you can look at CycleGAN. So last class we were just saying, well, in case that you don't have a paired data set, how can you create a paired data set? Yeah, in a more automatic, let's say, way without manually annotating, the data. So we were saying we can use a unsupervised method, somehow a CycleGAN that will learn to create this kind of translation and create the labels, yeah. But you can also use a CycleGAN just saying, I have DALI and I have Catalan architecture on the other side. Look at both domains, understand the underlying, in a way, representation of the two domains, and then create translations, yeah, between the two. Yeah, so at the beginning today, I was saying, that personally I consider CycleGAN to be the most creative network from the networks that I showed here, and mostly, I just see the process that the network tries to engage in as being more creative and more similar in a way with what we are doing. And it's also going to create something that is outside of the data set that we input, yeah. Creating something completely new outside of data set, when StyleGAN is mostly creating interpolations or, these kind of things, which are defined by the data set, yeah. So here I think will be very interesting, yeah, to really look at Dali's surrealism in a way, and then, look at Catalan architecture and see how you bring, in a way, that kind of super structured, rigid, in a way, architecture to this kind of like DALI, surrealism or something, So I think that a CycleGAN probably will have you'll have more fun with the CycleGAN, yeah, probably than with the StyleGAN. But you should try to run both of them, yeah. Try to run both of them. Have the StyleGAN more balanced in terms of data set, yeah. And then try also an experiment with CycleGAN, yeah. And you'll see that CycleGAN is going to just go nuts. It's going to be crazy, like super interesting interpretations that you'll never think of, because it's going to look at the composition from buildings and composition from DALI. And then it's going to create this kind of super interesting translations between the two, yeah. So yeah, CycleGAN can be used, very pragmatic, like I showed previous class, but it can be used in a very speculative way. And probably in that mode, it's more creative than other networks. Okay.
Thank you. I'll definitely try it out.
Andre, that was great. You had fun. I mean, I just want to. DALI did say something about architecture, right? He said the future of architecture will be soft and furry, and there were some guys that has been projects based on that. I once said this to some guys in China, and I said I think the future of architecture is going to be soft and furry. It's probably going to be like a panda, and for some reason, I don't know. This is broadcast everywhere. For the next 3 years, I get people coming up to me asking me why architecture is going to be like a panda. But it's probably a good thing to say because they were a bit uptight at the time. Of course, now the work they're producing is fantastic. But that was great, and I was keep going. That was fantastic. I mean, Edgar, followed by Julia.
Thank you.
Thanks. Edgar? Oh, he's just, I got to admit him. Okay, hold on a sec. Yeah. Hi. Edgar, we just
Hello?
Yeah, you ready to go?
Can you hear me? Yeah, sorry, I got kicked out from my iPad. So I'm just gonna share my screen now. There you go. Can you see? Hello?
Yes. Yes.
Okay. So this is my presentation. I started with the one that we started the example with Daniel's. So this is the two that I did before actually blending it. Came out to this. And then I did the circle interpol, which I found pretty interesting. And then from there, I just went directly to what I was gonna do myself, which was coral reefs. I decided to do it on coral reefs itself. This is one of the original images I used to train the data set. And these are the other ones I used. So I used, in total, I think it was 9 that I used. And then this is the first view that came out. And then this next one, I really started to like it when I started to mix it with the faces, because it reminded me of like Pirates of the Caribbean when the characters have like barnacles or algae growing on them. So I kind of liked it a lot, especially if you zoom into individual ones. It reminds me of that. Especially, I don't know if you can see my cursor. This guy right here, it kind of looks like he's like turned into like a crab. So I really liked that a lot. I thought about running it with this, but I didn't. This is some of the seeds that I actually liked itself. And then this is one of the truncations I did. And then the interpol, I have no idea if you're gonna be able to hear the noise. Can you hear the noise?
Yeah, slightly, but don't worry about it. Don't worry.
And then the second one I did was this one here. And that's it. Which I'm kind of pleased with how it came out, but I learned afterwards that not to use images that have like just blue in it.
Yes, this is what I want to say.
Yeah, because there's like 3 seconds in each one where it's just blue, and I don't like that at all. But if I'm going on further with this, and I learned that now not to do that.
Yeah, so I think probably Neil told you about coral morphologic, and maybe there you can find like high quality resolution for this kind of corals. Or maybe another thing will be, depends now what you're looking for. You know, if you're just looking for purely like aesthetics and colors of this kind of corals, then yes, you can, okay, use this kind of images of corals. But if you're interested actually in the structure of the coral and those kind of patterns that are created, maybe a better idea is to not create a data set with images of corals, but to have a 3D model that you render, let's say, into a rendering software or something, yeah, and then collect that data set, you know, for your StyleGAN, yeah, and probably that's going to give you a more consistent way data set and more consistent results afterwards, yeah. Because I think here this is also the question, like what exactly you're trying to learn, yeah. Of course, when right now we are just having fun with networks, but then later when you start to approach more precise, like architectural, a project, then there has to be a clear, like, why exactly I'm choosing this type of data set and not a different type of data set, yeah? So why this type of coral and not the other type, yeah? And right now, for example, the images that you have right now, they have all types of corals, yeah? And I think that translations are very hard to be created, not translation, interpolations are very hard to be created then between those types of corals, because you don't have for types of corals different or multiple, examples, yeah? You might have one type of coral that is represented by 2 or 3 images in your data set, which then is not really helping that much. So in a way, try to look at this kind of methods of how else can I create the corals, yeah? Should I use Houdini? Should I use like Grasshopper? Is there a Grasshopper add-on that will create this kind of coral geometries, and then I'm just going to render and I'm going to screenshot in a way those corals like that, or or how will that be done? So I think that will really help you also in the direction of controlling the output and really controlling also the type of information that the network will learn. Otherwise, like this, it's quite hard, to find a lot of images that are very clean and just representing one type or a different type, let's say, of coral. So yeah, probably you can try to look also in that kind of way, if you render them, if you have a 3D and you render it.
Yeah, there's coral morphologic for these kind of micro images, really close up images of coral, because coral's quite small, but they get really close up, and that can give you much more definition. Otherwise, you just get kind of coral reefs, which kind of a bit blurred.
Yeah, I that was one of the other things I didn't think about when I was looking at all the images. I wanted to get actual like patch reefs to see if it can make like fake patch reefs, but I didn't think about how the result would come out to, just simply because I've never done it before. But yeah, just running through it once, like I learned not to do it that way. But yeah.
And another fun experiment, because you were talking about the Pirates of Caribbean. So a fun experiment will actually be, if you have this kind of clean data set of corals, to have a StyleGAN that is looking at, on one hand, like faces, yeah, and the other hand, corals, and that asks to, to create this kind of translations between the composition of the face and the corals, and you might end up with some super interesting. Who knows?
Yeah,
maybe you end up into a makeup artist, for movies with those kind of things.
Yeah, I was actually worried to see how it would come out with the faces, but when I saw the reel come out, I was like, wow, that's actually really cool.
Yeah, so that could be a cool inspiration, for a makeup industry, like a movie makeup industry, So, yeah.
Oh, okay, let's move on. Thanks, Edgar. You had fun, right? I would go and do some micro images now and see if you can. Julia, are you ready to go?
Hello. Yes. Let me share real quick. Okay, let's share the screen because I'm not sure. Okay, so I used StyleGANs, and this was the first I combined it with flowers. This was the data set I used, and they kind of like morphed in, the faces morphed into the flowers, and the GAN actually realized pretty fast where the flowers are and how to create them. And but my favorite examples when I use circle interpolation, and so the flowers look like they were just moving to me. This one with the lower one, and this one was, and I try to use different methods too. Like I like this one too, but this one was truncation from small to high, and this one was, I think, just with a small truncation or something. But then I thought, because I was thinking of this idea for my project is how you can interact with the city with the visual devices. So I was like, what if I use the already system that I had with flowers and train on top of it the buildings? And I wanted mostly to see how it's just gonna morph into them. So it still needs a lot of work. This like run for like 7 hours, but it definitely needs way more because this was the last one that I had so far, that the buildings are still very squiggly, but then at the same time, when I looked at the differentiation, I kind of like the idea of how the building seems like it's moving on the wind and then transforms into like the bigger windows transform into the smaller one. And this one looked like a building transformed into like a tablecloth, and got something pierced through that. So like things like that, but this network definitely needs more training. And then I try to use CycleGAN, but because those examples that I showed you before, they were like so different from one another. Like for instance, here it had stripes, and here's they looked similar in the first glance, but then I couldn't train the CycleGAN as well, because what I'm trying to do is trying to create shapes, and if we can make build into it. So for next, I probably will try to use like similar data sets. Like for instance, like one building instead of like stripes and squares, something like that. I don't know. Yeah, and that's it.
All right. So I think the experiments are very interesting, and also the one with the roses, I think it's very interesting with the flowers. Yeah. So here, I think usually when I'm making these kind of comments, I'm making comments that also apply to mostly everyone in the class. So here, I think we also have to be very aware of which is the level where the information that we want the network to learn is situated at. Yeah. So for example, if I want to learn like aspects of just fenestration or this kind of windows and stuff like that, then when I'm creating this kind of crops, I should make sure that the crop is small enough so that it's just capturing those kind of moments. Yeah. If I want to have the network learn something more than just fenestration or windows and stuff like that, then the crop very likely is going to be bigger. Yeah. So I'm just making this comment because in your case, yeah, the results, they are mostly this kind of very small, like very zoomed in a way. Yeah. And probably they have to do with the crop size. Yeah. So then it's a question there. Yeah. Is this really the information that we wanted to learn, or is something else? Yeah. So that's a question, but then also it's a sort of observation, yeah, of the result. And you're saying, now I understand that if I have this kind of just crops and zoom ins of the building, mostly the network is just going to learn those aspects. It's not going to learn the overall composition of the building in a certain way. Yeah? So even if I input multiple images, let's say I have one image that I'm breaking it into smaller crops, the network is not going to be aware of the overall image. It's going to be aware of the just the crop images, yeah, and the semantic information that you have there. Yeah. So in that kind of sense, then it's good to be aware of, you know, I'm trying to have the network learn this kind of thing. So I have to be careful when I'm developing the data set so that the crop is really capturing those things. Yeah. Because then the output is really going to be describing those kind of things. So the same goes also with roses, for example. It's very interesting, guys. They are very beautiful, and also the move is very nice. It's this kind of very nice shift, yeah, of the petals. But if you want to have like a more global, in a way, let's say, composition of that, you'll have to have the crop bigger, yeah, and then you'll be able to interpret that kind of not interpret, but learn that kind of composition, yeah, that is more zoomed out, yeah. So you can play with those kind of things and then try to see different levels where you can apply them. You know, you're saying that you wanted to use also StyleGAN, not StyleGAN, CycleGAN. So imagine that right now you have this one, yeah, this output that is quite zoomed in, yeah. So it's just giving you some kind of compositional line, like directionalities and so on, yeah. But you can make an argument that actually this is intentional. What I want to do is I want to look at these kind of buildings that have this kind of facades with this kind of patterns, and I want to just extract, in a way, compositional, in a way, patterns from those facades, yeah. And then I'm going to generate, let's say, with that network, some compositional like rules and lines. And then on those ones, I'm going to apply these kind of rules that I have in petals, let's say, yeah. And then I'm going to have a CycleGAN that looks at petals and looks at, you know, flowers and this kind of more abstract compositional rules, and create a very nice composition now. So you can, in a way, try to combine this and try to think, in a way, at this kind of levels of design, yeah, and try to understand where I'm applying specifically the network, yeah. I understand that right now, you know, there are many people are using AI, like, or this kind of networks. You just look at the entire building. It's great, yeah. You look at the entire building and then the network is outputting completely new, this building doesn't exist kind of result, yeah. But if you want to use this kind of AIs, let's say, in the creative process, where AI it's not necessarily just creating design for us, but it's in a way helping us, engaging with us in this kind of creative process of design, yeah, then we have to look at, you know, which are the strengths of these kind of networks and where they can help us in this kind of process, yeah. I want to learn composition, let's say, from nature. So I'm going to have a network that's looking at a certain scale in nature, and it's going to learn that composition. And then I'm going to look at buildings, and I'm going to ask another network to translate the buildings to the composition from nature, for example, yeah. And then suddenly we end up with a super interesting creative process, and we end up with something that's completely novel, yeah, that normally as a designer will not, in a way, come up with something like that, yeah. So, I mean, I'm just speculating here, like ways how you can look at this, yeah. But overall, I think, again, it's really, really interesting.
Yeah, I agree. I try to do something with like buildings like this, and then to cut a pattern, and I actually kind of like the pattern at the end. But would you think what you mentioned, how organic would like translate into, would we have like the patterns from nature translate into urban? Like, would you suggest to do it in CycleGAN more than?
Yeah, something like that, CycleGAN,
yeah. Okay.
Something like that, CycleGAN, because what I want to have is I want to be able to give patterns from nature, and I want to have a network that gives me interpretations from building domain, let's say, gives me interpretation on that kind of composition from nature, you know. So in that way, yeah, you can do that with a CycleGAN, yeah. You cannot do it with a StyleGAN.
Okay.
So we really have to understand that, I don't know how many of you, okay, there are different types of creativity, yeah? And especially when it comes to networks. Most of the networks, they do interpolation type of creativity, yeah? So you have your data set, and then the network learns the data set and then creates interpolations, yeah? Whatever creativity is that, is still creativity in a way, you can say, because you have, let's say, two ends here, and the network is figuring out how to create the middle, yeah? That's still a creative output, let's say. But if you want to go outside of that domain that you're defining with your data set, for example, a StyleGAN will not do that, yeah, but a CycleGAN will be able to do that, yeah. And for me, that's why I'm still considering CycleGAN to be more interesting than StyleGAN. Of course, StyleGAN has this kind of very strong, in a way, interpolations, and they're very catchy. But personally, I consider personally from a creativity perspective, I think CycleGAN it's more powerful, and the concept is more elegant behind the CycleGAN. All right.
Thank you.
Thank you.
But yeah, I think you got some stuff material for Valentine's Day there with those roses. That was great. Emmanuel, can't see him here. I know that Maita can't make it, and Philip, his computer crashed. But we do have at least one DDES student, a candidate, Theodorus. Who else wants to present? Marina, do you want to present, or?
Yeah, I mean, I'll be very curious. I mean, if DDES is not showing anything, but I will be curious in a way, what's the opinion of the DDES candidates, yeah, of the work.
Well, I got some very positive comments on the WhatsApp. So yeah, no, they fantastic presentations from Eleanor. Stuff from Russia. No, I think it's great stuff, and I'm glad you guys have been throwing yourself into it. Also, Matthias had to go. He said congratulations. Well, it's not me. It's Daniel did this. Theodoros, are you here at the moment? And
yeah, I'm here.
You want to go show us your crazy?
Okay, I can show some. Yeah, I don't have as much actually as what was shown, but I can show. So 1 second. Let me see. So you can see my screen, right? Let me take away this. Okay, cannot reach the phone. I'm actually just still doing stuff.
Just a second. So we all saw the first image there was a research paper, yeah. So
yeah, sorry.
I used to say to everyone that if you really want to learn something, yes, one way is to really just go and take a lot of workshops and tutorials and stuff like that. But if you really want to learn something, you have to jump into research papers and try to learn in that kind of way. Yeah, I think that's the best way to actually grow.
Yeah, definitely. Yeah. So what I've been using is StyleGAN. It's a new version of StyleGAN called ADA, and a few days ago the PyTorch version of that came out. So I prefer that approach. And what ADA does is very good at low data regimes, which is where I usually operate. I never have a lot of data. And I actually trained it on a data set I created. This train valid doesn't matter for this, but anyways, I created like a few years ago, like, I don't know if I can see. So it's like a data set of about 18, let me put, yeah, 18 different architectural offices. And inside is just, Google images of their projects or stuff like that, right? It's not like quality controlled or anything, like maybe some of these buildings, don't exist or they're not theirs. This is Alberts and Van Hout. Some of them are a bit wonky on purpose. I wanted to have like different stuff, like Goody Clancy. I don't know if anyone knows. So this is the data set. It's about 3,000 images. And I think for these models is not really a lot. And then I trained, I didn't use any pre-trained models, although there are a lot available. So like Faces and Cypher and all this stuff. And I thought it wouldn't help, but people have told me since then that even the Faces dataset, which is really pre-trained for a lot from the official repo, helps for anything. So it can help for buildings or roads. So that's where, and then I trained it. I've trained it for about 1/20th of the official training guidelines or something like that. So 1/20th of the time, because my GPU just can't handle so much, let's say. And I'm going to show just a few results. Like it's nothing really crazy. So it's all about building. So what I've been trying to do, so maybe I show the grids first. Like what maybe is interesting, sorry. I've been trying to do is just generate building stuff. And this is like a sort of evolution. I hope this goes by time. So let's put by date modified. Yeah. So I started creating, this is the style mixing stuff. I don't know if anyone can see this. I can zoom in later. So what this does is it takes five different latents here and 5 latents. So this edge and top are 5 generated designs from StyleGAN. I do not believe they exist because you can see they have like some weird designs. And then the algorithm just mixes between them, right? And this was the first grid I created, and I think it looks quite nice. So you can see here, this building and this building, their mix is like very, towards grayish. And then, here it creates this glass facade. from this like very weird building. And what I like, and I've seen this in a few models, I'm not sure if this is true, this is just a small intuition, is that usually the more styles you mix, the more kind of Latin expressions you mix, the quality improves. I've seen this in a different model where they were actually mixing embeddings, and every time they mixed a new embedding, they would improve the quality of the outputs. I wonder if this happens here. Here it doesn't, so maybe it's a mistake. So here you can see it takes this texture and it applies it here. Very nice, I think. And this is my favorite, I think. A sort of like older school facade, and it applies it here. The same with the other designs. It has some stuff that are a bit more sketchy and actually look like sketches like this. It looks like a park somehow. I don't know. So it's not all perfect, obviously. Because I should say, for me, I'm not so much interested in something like this. Something more like creative or generative. I'm really interested in creating real buildings somehow. I don't think I will do StyleGAN, but with generative models somehow. So this is one approach. And then the more I would train it, I think the better results I will get. So here again, you can see how this picture maybe is the most striking. It kind of changes, into different areas. I have some cherry pick grids to show. This is not very good grid. I don't like it, but there was one grid that was nice. Okay, then I did 10 by 10, which was not the best idea. But you can see how it, again, like, it changes the style. It takes this, it does very good in this style, I think, in the brown sort of old school facade. Yeah, and you can see how it captures like greenery and landscape. I think it's very good for the amount of training, because again, this was trained in a lot more iterations. This is like the latest one. I should be scrolling, actually. That was a mistake. Yeah, this is the latest one. Like somehow these lattes were not very nice. This building is not very nice. It looks like a face. But what I like is how it transfers the landscape, because the original picture does have some landscape, but it kind of like feels like vegetation with everything. So it does very well. And then the other thing I will show, and I will stop again. I don't have a presentation, I'm sorry, because this is like happening in real time right now. Is a bit of the projection. So one of the projection I did is I took this picture of the Yew Garden, which is very, very difficult, I think, for the model. This is from, okay, my goodness, this is from Shanghai. There is nothing like this inside, right? This is completely odd. And the projection, what it does, it tries to kind of like take this image, it passes it through the model, and then it tells the model, okay, just mix this random thing that you created towards this image, just project it towards this image. And I think it's a sort of a variable evolution they do. And this is the latest one. So you see, it starts from a random building, and then it tries to push, let's say, the vector, essentially what this is, towards the left, right? And what I like about this is not only that it starts to capture the redness of the facade here, and even the structure, but it's the reflections. I think the reflections are incredible that it creates it. I've seen something like this before in StyleGAN. So in StyleGAN, I've seen images where it creates reflections, but the reflections are totally wrong. So it's like a person and the reflection is like a boat, I don't know. But here it's actually trying to create the reflection of this building, which really blows my mind, I think. So this is like one projection. And then because we talked about corals, and I'm almost done, I did a projection of corals. Did I delete it? I think this is the one. So this is like a weird coral. And again, these are not very serious tests because it's very hard to create something like this on the left. Like it's not even a building. And I think this is the latest one I did. And at the end, it manages to capture the whole circle. If it doesn't, it's the early one. Yeah, you can see how much harder it is. No, it's not this one. I had another one that I was showing, like, as the training was going anyways, it was better. And, then I did maybe like some Foster apartment. The other one is like the Tulip building. I think this was in Miami. I'm not sure it ever got built. I just found it online. And then again, you're trying to push the latent to appear like this building. And it does very well. And what I like about this is that it doesn't really care about this building only, even though I do. It gets, I think, the background as well. So it tries to create a bit of the background. Again, it's not a design. This is one of the issues I have with all this. Like, this is a nice you know, sort of capture, you know, abstract capture of this, but how do we move to design? And I think that's that. I mean, I have a few other of these videos to show, but it's not very interesting. Like this is how the three different iterations. So like this was very early on in the left, a bit more training in the middle, a bit more in the right. Somehow the reflections in the left are better, but they don't reflect what is actually above, while here it's starting to reflect the shape above. So yeah, this is what I've been doing, just StyleGAN so far, and I have some Foster and partners, but it's not so interesting. I think I will stop the share here.
Yeah,
but
well, these are interesting. These are very interesting, like explorations either way. I understand that right now you're just started training and you started to look into that, but I think it's super interesting. Just to address in a way like this kind of what you're saying, you know, about projection. Yeah, we are projecting, and then you're saying that you don't really know if that's really creative. I think where we get to creative, it's maybe in the part where you have the grid interpolations, yeah. And right now, I think that works mostly just at the stylistic level. I think you're just addressing, or probably the way you have it set it up is just there is a level of resolution that's going to be to affect. If you are looking at those at the latins, the columns and the rows, you'll see that always the rows you're just taking almost like the texture and the color and applying it on the columns, yeah. But you're not really doing this kind of like composition, let's say like lower level. Like if you were to access, let's say 32 by 32 with 64 layers or levels, and at that level to create the translation, you'll end up with a building that is, let's say, a bar, and the column, let's say it's a tower, and then you end up with this kind of interesting morph between those two, yeah. And I think that's where we actually start to be creative. And I think this is the cool part about this kind of networks, and especially StyleGAN, because it's able to disentangle that well the features, is if you can literally say, you know, like, I want only these features to be applied to this column, yeah? And then you have those features translated onto the column, yeah? Right now, I think what you have is mostly just stylistic, like, you know, you can say color and maybe high resolution or high level, you know, information, but not so much the composition. I think once you start to jump into the composition of it, I think that's where things start to be very, very interesting, yeah?
Yeah,
it's this kind of like this kind of arithmetics, you know, arithmetics between latents, you know.
I haven't seen that anywhere in StyleGAN yet. I did find something about where they edit specific parts of an image with StyleGAN, but the closest to what you're discussing, I saw it in DALL-E, which is not open yet. That's where they really compose stuff, so I'm really excited about that.
You have to look into StyleGAN 1. If you look at StyleGAN 1, you'll see that there are some, StyleGAN 1 has a few examples of style mixing, yeah? And the style mixing there, and I think if you even go on NVIDIA, like lab, on their GitHub, the original one, they have a style mixing method, and that one, it's beyond just, you know, like this kind of high resolution, you know, information. You can also access the low level. So
I will check that out. Thanks.
That's super nice. But either way, I mean, also those projections are very, very interesting, and I think, you know, that's the interesting thing here. And for us, for example, Kupion-Blau, the DPM-Blau project that I'm developing, it's not necessarily a StyleGAN or CycleGAN. It's like a sort of combination, like it's borrowing ideas from one, from the other, you know, multiple kind of methods, and they are combined and they create this DPM-Blau network. But there is the same thing, is like, you know, we create a data set, let's say with images from Kupion-Blau, but the end goal is not to have a network to output images that look exactly like Kupion-Blau, you know, like our buildings, our past buildings, yeah. That's not the idea, because then it's like we don't really need the software to just interpolate between our own buildings, you know. If we want to have an AI, we want to have an AI that learns our style, and then it's able to somehow create new images, yeah. So then also here, like the data set that you start to put together, it's like, how do I put that data set together, yeah, in order to end up with results that are very, you know, novel. They're not just so that the network is not only outputting for me the exact images that I have in the data set, because that's not really that interesting. It's interesting as a learning exercise, but not for us from a creative perspective, So yeah, I think that's where, these are the challenges there. You have like the data set, how you have the network then learning correctly so that it's not just learning the data set itself, but it's also able to create something completely new, and then how we control that kind of output.
Yeah, I agree. Thanks.
But yeah, it's amazing. I mean, all that work, it's amazing. And yeah, by the way, I'm also a fan of PyTorch. I'm also writing in PyTorch. I don't like TensorFlow.
Yeah.
But
There is I saw an advantage of TensorFlow that people I've seen in the community, they use, like, you can apply for the TPUs. And I think because you're also like, a researcher, you could, but I cannot work with that. And I applied and they haven't responded. So maybe that's just a dream. But yeah, PyTorch is much better. Yeah.
That was good, Theodore. We've got, I think, Marina, you wanted to present yours. Is there anyone else want to present? Okay, let's, Marina, go ahead.
Okay, I'm going. Hello. Okay, so my presentation is going to be a little bit more sensible, but it's the first time I'm using this, so I hope I learn a lot anyway. But the name of my experiment is Nullisms, and what I am, just a second, okay. So what I'm going to try to do at least is to try to make my presentation a cycle again. I mean, it's going to be a cycle, not CycleGAN, but a cycle at least. So my first intuition was try to work with something which is related with my actual research for the thesis. So when I started my research, I started to look at for these maps, which are in a way architectural maps. They are trying to map tendencies in architecture. Maybe the first one, which is a Piranesi map, is more plans, architectural plans, but you have like this kind of segments, but at the same time you have like things which are like mixed or try to go together and then try to separate. I'm explaining all this because it's in a way it's part of some logics that I was trying to use. The map in the middle is Charles Schenk's diagram, which is more evolutionary. You have like a line of time, and then you have like different tendencies. And inside this, all these texts are architectural office or architects. And then you have this timeline, and it's like a kind of evolution. And this is the second map of Schenk's, but he had another before. And then you have like the Saera Polo diagram with Guillermo Fernandez Abascal, which is global architecture political compass, which is like try to cut in a synchronic way the Schenk's map, but with architectural practices, their office as well. And then you have like different different tendencies, and they are like more political into the center, and then okay, it has like a different logic. But in a way, what I was studying, and this I'm doing all this to explain where my data come from, is which is biases of course, at least until now, it's super biased. But it's this idea of the megalomaniac frustrated architect, which is an architect that cannot build. So it tried to occupy everything with the architecture that he couldn't build. So they're their designs. So you have like the first map is Nolly's map, which is more a cartographical study of Rome with the public spaces. And the second one is a Piranesi map. And where I go with this on my, at least I'm trying to make an image of my thoughts, but in a way what I studied there is like, this is a competition, Roma Interrota, in 1978, and then you have like each square is an architect, who designed, and you have Sartogo, Dardi, Gumbrach, James Stirling, Portoghesi, Shurgola, Venturi, in the order that I'm reading from the top to the down and from left to right, not like a book, like an Occidental book. Venturi, Rowe, Graves, Creer Brothers, and Rossi. So I'm going to focus on the Stirling because what he did is to put his own building that he didn't build in this map and try to, it's like a kind of collage technique. But in a way, you can see in the two squares on the left and the right that you have like how he works. What is the logic? So this is the Derby building, and it's like trying to recompose in a way the block, but it also has like a kind of a new highway, and public space is absolutely different to the Knowles plan, because this is using the Knowles plan. That's why. So let's go to the dark part of the presentation, which is my experiment. And then I call it Knowlism because the data is the Knowles map. And this is what I did. I start to make some, I mean, I try a lot. I try with different trainings and things. And one thing that I notice is, first of all, that I need to manipulate data before to start training. So one thing that I did, I inverted, because it will be easier to the machine to recognize with the other data set that I use, that is La Plata. I'm from La Plata. This is the city where I live and where I born. And so La Plata is a regular city, and you have like these diagonals, which makes like cut the blocks, and it generates like differences. And you also have like difference with the blocks that going to the center edge, you have like the blocks are going smaller, and near to the borders is going bigger. So what I have to study first is what to cut. What is going to be the scale, that what is going to be inside the picture, and what I'm going to let outside first. The other thing that I start to study is like what I was saying about the Knowles, and the upper part are the real ones, and the down part are the fake ones. So what I notice is that because of the image is not a satellite image. It's an image taken from the flight. It's an old image of La Plata. And what I notice is like, for example, the roofs are more white. So inverting the situation, because the Knowles, you have the solids, which is like one color, and then you have the street, for example, and open spaces and empty spaces, which are in real is the opposite. No, is white and black, and here is white, black and white. So what I did is try to understand this, that I need to make the pair more compatible. So the machine is going to learn easier how to identify the pixels and the borders. Because what I noticed too, when I started to play with Barcelona and the grasshopper images, is that the boundaries are like really precise. Even the color, because of the color of Barcelona, it's like super identifiable. Where is the solid and where is the empty space? Here is not. So it's a little bit tricky. So I try to manipulate that. And I also discover, for example, some interesting thing, that how the image of La Plata in the Knowles plant start to cut like this little, like a kind of porosity on the block. So that could be interesting for me. And there is the right one is like the unexpected outcome in a way. So the first one was more what I was looking for, what I was imagining, and in the right is like something unexpected that I start to pay attention to it, because it's like more it led me to speculate more in a way to new kind of geometries which are not regular. So I started with a regular geometry, and because the nollie sometimes has like, when I cut the image, it has like this a regular shape, it started to translate this to geometries. But it was really interesting also because the nollie plant, in this case, what you have in this dark part, for example, is like they are like empty spaces, but it has like a graphism, it has like a drawing. So because it has like a drawing, when I translate, when the machine translated the image of La Plata, it filled it with density, which was one of my first objectives. Try to think how, try to, in a way, give to the nollie plant more density that I have in La Plata, to put it there and to see what is happening, and to see how this can be, can have like more porosity and differences. This was really interesting too, because this is all different epochs. I made like 70. I didn't have more time to do more, but I would like to continue. And what I start to do also is to manipulate the data and to replace data. And for example, I start to distort La Plata's grid to make it more compatible with the nollies plan, to make better this translation from one to the other. And then to have like different kind of images which are more compatible and images which are not, and to see, I start to test what was working and what was like pure noise, and I couldn't like identify anything. But the results were started to be even better, because I start to see that I have like these paired images. It was like more less obvious which was the relation between the images. And so I played with the rotation, I played with the crop, with the image, with the scale also, and with different distortions to that grid. And so trying to make this cycle that I was saying, what I was thinking about this, because you have a lot of time to think when the machine is training and you are testing things and you have a lot of time to think. And what I was thinking is like, in a way which is related with this idea of diagram that I showed before, which is part of my thesis, is that it's not absolute. I mean, it depends that the image is not necessarily two-dimensional. Because in a way, we see everything like in a kind of Euclidean way. So we believe that it's bidimensional because you have y and x to say something, and you need z, for example. So we always think like it's like it has to be three-dimensional, like a volume. But it's not necessarily true, because when you manipulate data, for example, and you see in this case the nollie plan, which is like super old map. It has like a multi-dimensional level, because you have names, for example, or you have this graphism for the farmers' places, and then you have like the solids, and then you have another graphism for the water. So this is all different layers of information. So when we see that, we understand that it's not bidimensional. It's multi-dimensional. It's in an informational way. So I believe that if we can manipulate this, it doesn't have to be necessary three-dimensional to think one space, because they are like multiple conception about what a space is. Today we perceive everything like, I don't know, in a perspective way. So we believe that we are like training to see in that way. But I believe that one thing that we can understand about these diagrams is that they have like several dimensionals that are not bidimensional. So I don't believe that this is something to criticize to these processes. So yeah, thank you.
Thank you. I think it's great that that you go so granular in a way to try to look at all those factors that might affect and might influence, you know, the data set and the network and so on. And I think in a way that's a good approach in a way. If you really want to have a network that really learns things correctly, yeah, there's going to be a lot of effort that needs to be put into understanding the data set, understanding in a way what kind of information, how the network will work, how, you know, conceptually how you think about the data set versus the network way of learning. You know, I think those aspects are going to be extremely crucial. Yeah. So of course, right now we are looking at it from an analog perspective. Probably there are other methods that we can deploy that are more digital that will help us in a way to really analyze correctly this data. But that's a different kind of discussion. But I think it's very interesting. Yeah. So for me, it will be also interesting, like is there a way for us to in a Nolly map? Is it a way for us to really extract all those layers that you were mentioning just a few minutes ago? Yeah, you were talking about different layers that are encoded in that map. So that will be in a way things. Probably the network learns by itself, yeah, like just by looking at it and without even understanding that what that layer is. It's just going to understand that a sort of pattern next to another pattern of pixels, yeah. But yeah, for us, for sure, if we want to like have the network be aware of those kind of types of layers that we have, probably we have to segment things and then ask the network to look at them separately like that, yeah. Almost like to already know that there is a differentiation, there is a distinction between the different types. Yeah. So yeah, I think it's great. Yeah, I think it's great, and probably many of the master students can look also at the way you approach data set and maybe learn something from there. Yeah, in the sense of you really have to like understand. Okay, the network it's working this kind of way. So my data set that has to be like this. Yeah. So you're saying, you know, one data set, I have the rooftops that are more white and the streets are more dark. And so maybe I have to flip it just to make sure that the network understands correctly what I'm trying to describe here, you know? So I think all those things are super great points, yeah, that I really like say, congrats, you know, on picking on those kind of small details, you know?
Yeah, just I could add something. I mean, I think it was great work, Marina, fantastic. And I also appreciate the kind of the flipping and so on. One thing that really struck me though, and maybe, I don't know, Daniel maybe can comment on this more. When I was visiting Refic's office once, he was showing me one of these kind of the clustering you get when you go through StyleGANs, and he had a whole range of different architects. You know, there was Zaha, there was Toyoito, there was, I don't know, Foster or something like that, you know, Gary and so on. And actually automatically the system kind of clustered them and separated them. You know, they're obviously buildings rather than architects and things, but there was a process and operation in that thing. And so that was one thing. I just wonder, I don't know, this is a question really for Daniel, whether that clustering could be kind of compared to that Charles Jenks or Alejandro Zarapolo model in any way. Maybe not. But I also thought the kind of the morphing that happens when you take a kind of trajectory through one of those clusters is kind of similar to the flow thing. So there are lots of kind of parallels, and I'm not quite sure what it is, but there's something really potentially very interesting there. Daniel, is that how do the clusters work exactly?
So very likely what you're referring to UMaps or self-pronounced maps or K-mean clusterings or Disney, which are like types of machine learning, let's say algorithm. I mean, self-organized map is not really machine learning, it's mostly a neural network already. So there are these kind of algorithms, yeah, that try to cluster, and mostly they are based on dimensionality reduction, most of them. So dimensionality reduction, what it does, you look at n-dimensional data. In our case, for example, a latent space, yeah, it's an n-dimensional space, yeah. And for us as humans, even 3 dimensions is very hard to comprehend many times. So then the idea is how can you map in a way the latent space so that we as humans are able to comprehend it, yeah. So then what you're doing is you're looking at, you're using this kind of autoencoders, they are called, yeah. So you're trying in a way to map the input to the output. You're trying to have a network that tries to learn in a way input and output. So what's going to happen there, you have a lot of layers as an input, and then you have just 2 layers, let's say in the middle of the network, and then you have the same number of input layers as output, yeah? So like that, the network is trying to compress in a way the information and then expand it back, yeah? So it's almost like this kind of process of, I'm reading a book, and then you are asking me to tell you which is the topic of the book. So I'll have to compress somehow all that knowledge that I read, and I have to compress it in one phrase, for example, yeah? That phrase has to represent in a way the book that I just read, yeah? So it's this kind of compression, yeah, that's happening. So then dimensionality reduction happens in the same way. You have a network that reads the entire space, but then it should be able to give almost like a summary that it's able to give us, you know, an understanding of what the entire space is about, yeah? And then it's creating this kind of 2D map, yeah, in a way. 2-dimensional map that has also this kind of location, in a way, rule, where more similar versions are placed closer to each other. The similar ones are further apart, yeah? And this is, for example, a self-organized map, or also UV map. I think it's not UV, UMAP. It's working similar way. The other one came in clusterings at Disney. They have a different kind of idea behind, but that's overall, that's the idea, yeah, dimensionality reduction. You're trying to bring the n-dimensional space to 2D so that you as a human can look at it and understand it, yeah? And those clusters, in a way, they just emerge because in the end, the information that you give, like different styles of architecture or different architects, even if they are images, yeah, the content, in a way, is described in a certain way, yeah? So they are more similar to each other, yeah? And for example, even if you were to use VGG, or how they are called networks, perceptual similarity networks, where in a way you have networks that are looking at two images, and even if one image is blurry and the other one is sharp, it's still going to be able to tell that they are the same image, for example, yeah? Well, because perceptually it's able to understand, yeah? So in this, in a very similar manner, yeah, you can create then this kind of clustering and, you know, sorting of the latent space.
No, so
yeah, it's really based on this kind of idea. That's the easiest way I can explain it.
Yeah,
it's like,
I mean, so
I have a great. I'm reading a great book, and personally, I have to somehow compress, encode in a way that information, and
right.
then, you know, just say it into one sentence or 2 sentences.
Well, but that's precisely what's happening with the Charles Jenkins map in a different way. You know, there is a kind of compression of information into simplistic terms. So, I mean, I don't know. I think it's a thought exercise. I mean, you should take with you and think about whether that's going to be relevant or not. But it just struck me as being an interesting kind of comparison in a way, and completely reductivist in some ways. But Daniel, one thing just before we wrap up, I think we're towards the end here. But do you want to kind of post something about your Clubhouse discussion tomorrow?
Yeah. So tomorrow I'm just trying to run a Clubhouse, you know, a discussion. It's going to be just a chat. Yeah, it's not going to be something like, you know, specific topic or something, but it's just a way maybe to, you know, to bring together multiple people that deal with AI, perhaps computation, AI, just, you know, just a common discussion. I don't know how many of you already have the Clubhouse app.
I would love to come.
Amazing. So I just posted the event on the chat. So maybe you can go through Clubhouse. Like if you install the app, you'll see what you have. You have the wall, yeah. Usually in Facebook, yeah, you have the wall, but here it's considered the hallway, and then you have different rooms, yeah, that you can access, yeah. And those rooms usually, like, you go from this kind of top of the industry kind of people to like just normal people like us, yeah. But you have this kind of like, you know, Silicon Valley in a way, venture capitalists in a way in some rooms talking about startup, others talking about, you know, other topics. Yeah, it's just amazing. Yeah, it's a sort of like audio social media, let's say. Yeah.
Can you invite us maybe, or how do we? Is it invite
yes.
only?
So so I can invite. I think I invited Neil, and then Neil gets automatically another invite. Yeah, and then the other invite is able to invite somebody else, and so on. Yeah.
Do do I have to, can I just say share it on WhatsApp, the same invite, or it has to be specific to me?
I think it's specific to you, and then you have to make it specific to others, and like that, in a way you propagate, yeah.
Okay.
So right now, I think it has 3 months or 4 months, the social media, the Clubhouse, yeah.
I'm wondering if you could send one to Theodorus. He could, because I'm going to be so busy putting together my thing.
Okay, so Theodorus, for something like that to happen, I'll need your phone number.
Phone number, okay.
Yeah.
Okay, thanks.
So if you send me a email with your phone number or message with your phone number, then I can add you to my phone book, and like that I can invite you.
Okay.
Okay. But it will be amazing. I mean, it will be amazing, you know, to have a chat. You'll see it's very interesting, like experience. I think it's more interesting than, you know, visual, like because it's almost like you're talking on the phone, and you have the chance to listen in to somebody talking on the phone, you know. Because you have this kind of idea of, you know, there are a few people that are invited on the scene, on the scene, and then the other ones, they are just auditing in a way, yeah. So only the people that are on the scene, only those who are able to speak, actually, yeah, and the rest they can almost like just listen, yeah. But it's very interesting because it's almost like a phone call, yeah. It's just that you are able to tap into that phone call and listen in a way. Super interesting discussions in the end.
That was, I mean, have you invited Elon Musk to this?
Yes, exactly. That was also Elon Musk. Yeah, he was there too. I mean, Neil, then you know the experience, yeah? How Clubhouse is.
It was mind blowing. I think I was on a live stream from it though, rather than the thing itself. But it was.
I was trying to get into the room, and I was before it even started, and it was already full. Like, it was just insane with Elon Musk. Yeah.
But it was just, it made the international news. It was just an incredible thing. And I must say, you know, Elon Musk came up with some interesting kind of, the most interesting, I don't know what it is, but he kind of was very forthcoming with ideas and comments, and it was just fascinating, absolutely amazing.
Yeah, it's almost like you just hear his train of thoughts. It's not like, you know, this kind of filtering, like this is an interview and this is that and that. It's just train of thought, just casual discussion. And I think it's just amazing.
Yeah. So, okay. Just to say again, at 9 o'clock tomorrow, Eastern Standard Time, there's a theory AI workshop that I'm, well, workshop is a panel discussion, shall we say, that I'm kind of hosting and for the DDES thing. And I think that's going to be super interesting. And Matthias and then hopefully Daniel and a few others will be there. So you're most welcome to kind of follow on to that one. I'll send you the link. So there's a lot happening, Daniel, I just want to finish by thanking you so much for this. This has been incredible. I'm not the one to be thanking you, it's the students, because I think you've inspired them. I'm always worried when introducing anyone to some new technologies and techniques and things, but the enthusiasm which they grasped it and the excitement, I think, anyway, I can't speak for them. They can maybe speak to you for that, but thank you so much, because it was, I think you've really opened up some new territories of exploration. And I think I got the sense everybody really enjoyed this exercise, but I'll let them say something.
Yes, thank you so very much, Daniel. We learned a lot through these workshops and the way you explain the concepts. I think it gets through to a lot of people, which is why everybody gets to be so excited about it.
Amazing to hear that. I mean, I'm always trying. Nico, he was in my FIU class when I was a visiting professor at FIU. So also there, I was always trying to keep, in a way, the jargon down, in a way, not to be too overwhelming, because even like this, like the entire technology itself is very overwhelming. So then I'm always trying to explain things like with very, very common language and, very simple concepts, so everyone can get it,
Yeah. No, that's fantastic. So there's an ongoing series. I'm feeling like I'm bombarded by kind of these Zoom events and whatever. Clubhouse events now. Next week, just remind you that on Saturday we've got, well, tomorrow we can talk about the theory of AI and creativity, and on Saturday on Digital Futures we have Refigal and a few other people doing something on showing their work about AI and creativity. The following day on neuroscience and AI, and I'm hoping that Refik and Anil Seth will be there. Both for that discussion, but certainly there'll be an amazing discussion there. So it's a kind of ongoing debate. And, you know, I think also these things have been shared out there. So everyone who's kind of following it on the live stream, please join us again. And what I love about this is the fact that we're straddling all over the world. There are people in China who are listening, and Anna in Australia and so on. And it's kind of showing this information in a fantastic way. Finally, I'd say this morning there was the most extraordinary session of Digital Futures with some young people who were, it was about interactive design, but really it was about reinventing what architecture is about as a discipline. There were people who just completely kind of caught up in a kind of wave of new invention, who were just redefining what it is that we as architects can do. And I just would recommend you have a look at that. It was mind-blowing for me anyway. I don't know about everyone else, but so thank you, Daniel, and thank you to the team who's been live streaming it, to G and Janan and Yu Yang. Thank you so much, and to be continued. So please come and join Daniel on Clubhouse tomorrow. We'll find a way of trying to spread the information, and also tomorrow. Well, I say morning, but it could be evening for wherever you are. Tonight, for some people in China, the event on AI and creativity, the theory event. So thank you so much.
Thank you, everyone.
Thank you.
Excuse me, Neil. I posted the information for your talk in the chat.
Okay.
Thank you, Daniel.
Thank you, Gustavo. Gustavo, I'd say we have some of the Digital Futures team here with us, and they were responsible for setting up the session this morning. I know that Virginia's here, and Gustavo, you're doing a fantastic job. I think people, they always thank me, and they shouldn't be thanking me. They should be thanking those who kind of set it up. So thank you so much. And thank you also, Daniel, for what you did last summer. People don't know, but Daniel automated the whole application process, and suddenly it was that allowed us to welcome 12,000 or so applications, and without him, it would be impossible. So thank you, Daniel. That was a very generous and selfless act of yours. Okay, good.
Thank you, everyone.
Thank you.
And have fun. Enjoy it. Don't do it if you don't enjoy it. If you don't have fun, don't do it.
Exactly.
Okay?
Exactly. All right.
Bye-bye.
Amazing.
Bye. Thanks,
Thank you
Bye,
so
everyone.
much for everything.
You've got a
You're
fan
welcome.
club here, Daniel. Got a fan club.
Bye, everyone.
Yes,
Thank you. Bye. See you tomorrow.